Okay, what we're going to look at now is what we call stretching graphs. Now, I find stretching a little bit of a strange word to describe it, but that's fine, we're going to go with it. Okay, now when we talk about stretching graphs, what that means is we're multiplying it by something, basically. Okay, now in what I'm going to start off with is just a linear equation, so you can see what happens with a linear equation. Then we'll look a little more closely at a quadratic function. Okay, so let's look at the function y equals half x. Okay, you know it's going to go through 0. Okay, half of 1 is half of 2 is 1, okay, etc. Alright, we can make a nice pretty line that goes through all of these. Okay, so we end up with something like this. Okay, this is y equals half x. Now, if we stretch this, so let's say that we want to, and you'll see it written as multiply by a factor of, let's say, 4. Okay, now think about what the equation will be first of all. So if we multiply this by 4, half of 4 is 2. So we're going to end up with y equals 2x. Okay, but we can also show this graphically without too much fuss if you take a look at each point on the graph. Okay, so if we look at 0, this is the one that I want you to really think about. Wherever the 0 point is, okay, if you multiply 0, so your x is 0, if you multiply that by something different than what you originally had multiplied it by, it stays a 0, it's never going to change. Okay, so this 0 point is still going to be, we're going to do it in green, it's still going to be a 0 point, that's not going to change. Alright, if we had a point of 1/2. If we multiply y equals a half by 4, okay, we get y equals 2. Okay, here we had a point at 1. If we multiply 1 by 4, we get 4. Alright, here we had 1.5. If we multiply that by 4, we get 6. Okay, now let's look at the negatives. So some people think you multiply, you always make it bigger. Alright, but if we multiply minus 1 by 4, we get minus 2. Sorry, if we multiply minus half by 4, we get minus 2. At this point, our y was minus 1, so minus 1 times 4 is minus 4. Oops. Okay, so you can see what's happening here. We're getting a nice different line. It's still the same shape as the original one, obviously, because we've got straight lines here, so it's not going to ever change. But this is basically how we do stretching a graph. Okay, we have stretched it. We've taken the original graph and we've just stretched it. We've made it taller, basically. Okay, we've stretched it in a vertical direction, and that's actually something we need to specify. Okay, we multiply with regards to the x-axis 4. Okay, so multiply with regards to the x-axis times 4. All right, now this is something that you will need for next year as well. Okay, so it's something that we do want you to understand quite well. All right, let's try another one. So this time I want to look at a quadratic function. Okay, because that's what we're working with at the moment, isn't it? All right, let's just draw one. Okay, I don't care what the function is at the moment. Okay, I just want to have a look at what happens with it. So let's make it go through this point here and this point here, this point here, and we'll just go through these here. Okay, so this is going to be our quadratic function. The midway point will be 1, 2, 1, 2. It's here, so we're going to curve back up already. All right, so let's pretend that this is our very messy, but this is going to be our quadratic equation that we're going to look at, our quadratic function. Whoops, the pen switched. All right, this is our quadratic function. Okay, if we want to stretch this, So if we want to stretch this, so we want to multiply with regards to the x-axis, and this is important to include because we can also stretch it horizontally, but we don't do that very often at the moment. Anyway, maybe later you will. And then we need to say the factor. So let's say by 3. Okay, so let's look firstly at those 0 points. Those 0 points, as we said, they never change. Okay, we said that this point here was -2. You can see that on our, we've gone 2 squares down. If we multiply -2 by 3, we get -6. So it's going to be now all the way down here. Okay, it's going to get a bit messy, but that's okay. All right, let's find another intersection point. Let's pretend that this was an intersection point here. Okay, so it's not, but we'll just say it is. So this is 2, so we're going to multiply that by 3, we get 6. So it's going to now be up here, all right, up at 6. This one here, again, we'll say that this is an intersection point. If I mark it in black, it looks more real. Okay, let's say that that is an intersection point. Again, that's a vertical position of 2. If we multiply that by 3, it's now also going to become 6. All right, and the next point will be off the charts. Okay, so we're not going to worry too much. So now if we join all of these, we're going to have a vertex down here somewhere. Okay, so if we join these points, this is our stretched graph. Very difficult to draw it nicely. Okay, but this is our stretched graph times 3 of the original function. And that's what we want you to get used to at the moment. Okay, but also we want you to get used to looking at these as functions and what we actually do with them. Okay, just looking at them algebraically. So for example, if we have y equals x squared plus 4x plus 2. Okay, and I said to you we're going to multiply or stretch, whatever, multiply with regards to the x-axis for a factor of 2. Okay, what that means is we're going to do, let's write the equation out again, x squared plus 4x plus 2. We have to multiply the entire thing by 2. Okay, so this is now going to become 2x squared plus 8x plus 4. All right, this is all we're doing. Now, you guys haven't usually been working with your formulas in this form lately. Okay, we've been working with things such as if you have y equals x squared, what happens if we do the following things? Okay, so we can do this in 2 ways, and I'm going to show you the difference between the 2 ways so that you can see what happens if we do them in a different order. Okay, so if I said to you, I want you to transform this by multiplying the x-axis by a factor of 3, okay, and what you're also going to do is you're going to translate with, let's say, 3 minus 1. Okay, on the other side, we're going to do it in the other order. Okay, so we're going to do translate (3 minus 1), and then once we've done that, we're going to multiply. All right, now the first one. Okay, if we multiply by 3, we've got y equals x squared, so it's just going to become y equals 3x squared. Okay, if we now do the translation, okay, we now have y equals 3. Now, we want it to go to the right 3, all right, because this is x and this is y. That's the 2 translations we're doing. So we want to go to the right 3. So remember, this becomes x minus 3 squared. Okay, so we replace the x with x minus 3, and then we've got minus 1. Okay, so this is what happens if we do the multiplication first. Okay, if you do the translation first, it actually changes the resulting equation. All right, so let's try that. So we've got y equals x squared. If we translate it 3 minus 1, we get y equals x minus 3 squared minus 1. Okay, now if we then multiply, this is where, as I said, it becomes a little different. Okay, we're going to have, let me just write it out the long way again this time, x minus 3 squared minus 1. If we multiply this by 3, you need to remember we're multiplying everything by 3. So it's going to become 3 x minus 3 squared minus 3. Okay, so for this reason, the order that you do these is really important. Okay, we can now say for the first one that the vertex is going to be 3 minus 1. The vertex in this second one is going to be 3 minus 3. So it actually changes this quite a bit if you do the translation before the multiplication. Okay, so please just be aware of the difference that the different effect this has on your function. All right, mostly what I want you guys doing right now is just practicing using these steps. Okay, so both doing this just algebraically like we've done here, looking at how to get from, for example, x squared to 3x minus 3 squared minus 1, you need to be able to move between them, okay? And otherwise, we want you to also be able to draw these like this, okay? But that's not a huge part of it. That's more just so that you can see how it works. Okay, good luck.